You and I take a look at an IP address and we see it in dotted decimal notation and we go, ah. Yeah, because we humans like to think in terms of decimal. But the machine, your computer, sees it as binary and works with it in its binary form. We're going to learn how to convert from decimal to binary and in the other direction in this nugget, an important precursor skill for your ability to supernet and subnet. Now, I've got some great news for you about a tool that's going to help you tremendously whenever you're in a entry-level networking certification or even some of the higher level certification exams. And this chart is going to help you do all kinds of math when you're in this particular exam involving IP addressing. We'll use it again and again and again as we take a look at the Juniper certification here that we're working with. But here's the chart and here's how you build it. I begin by saying 2 to the 7th power, then 2 to the 6th, then 2 to the 5th, then 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0. And then what I do is I go ahead and solve for these values. And I'm showing you, notice I intentionally didn't make this pretty. This is exactly how I build it on my scratch paper when I am in the certification exam environment. 2 raised to the 0 power, anything raised to the 0 power is actually 1. Anything raised to the 1 power is that number itself. And guess what? You just double as you go through here solving for these values. What are these values? They are indeed the values that we have in the 8-bit positions in an IP address octet. That's right. So if you look at this position, it's 128 all the way down to 0. If you add up those decimal values, it's 255. And of course, we know that's the largest number we can have in an octet of a TCP/IP address. So you need to, if you don't already build this chart with great speed, I want you could do it now. Pause the video and go ahead, practice building this chart again and again and again and again so you can build it as quickly as you saw me build it. When you're done with that practice, unpause this particular nugget and let's work through using this conversion chart in order to solve a particular decimal to binary conversion. So here we go. Let's say we are in the exam environment and they tell us about an IP address. Let's say it's, how about 208.10.14.172, and they want us to convert that first octet into binary for them. All right, well, here we go, and you're about to see how terrible I am at basic math. Filling you with confidence, because if I can get all these certifications, of course, so can you. Here's what you do when you do the conversion. You go to this first position in your chart, and you say, can I take that number away from the number I need to convert? In other words, let's draw out our 8-bit positions here. What is the value of the first, and by first I mean leftmost bit position? Is it a 0 indicating off, or is it a 1 indicating on? Well, it is a 1 here. Why? Because 208, we can take 128 from it. In fact, it leaves us, there's a 0 there. We got to do some carrying. It leaves us with 80. Oh gosh, I'm actually better at math than I thought. Then we move to the next number, 64. Can we take 64 from our remainder? We can, so this bit position is on. 64, we do, oh man, more complex subtraction here. That's a 6, that's a 1, so we have 16 left. Can we take 32 from 16? No, we cannot. Can we take 16 from 16? Yes, we can, and we're done. We can't take 8 from 0. We can't take 4 from 0. We can't take 2 from 0. We can't take 1 from 0. So I propose that 208 converted into binary is 11010000. But wait a minute. in my practice, I need to confirm that I'm correct. So I got a couple options here. I can call Keith Barker and tell him to please convert 208 into binary for us. I suppose I could call Jeremy Chara here at CBT Nuggets. He hasn't been taking my calls lately. You know what? Let's go ahead and do a calculator. Now, you wouldn't have this ability on your exam, and that's because they don't want you to cheat and arrive at the answer with a calculator. But when we're practicing, it's going to be a great tool for us. So notice I've taken my Windows standard calculator and I've gone into a program review. Congratulations, you're a programmer for today. And we can type that number in. Notice we're defaulting to decimal here. So I say 208. And then I click the binary button and it gives us a binary conversion. In fact, it's even better than that. It's giving you the binary conversion right there. But obviously, if you want to see it in more bold print in the results window, you can by clicking binary. And we discover that we did it right. 208 in binary is indeed 11010000. Let's try another one. So here we go. Let's try a second one. The number is 59. 59 is in an IP address. We need to convert it to binary. Here we go. I draw out my 8-bit positions. Can we take 128 from 59? No, we can't. Can we take 64 from 59? No, we can't. Can we take 32 from 59? The answer is yes, we can. That's going to leave us with 7 and a 2. That's going to leave us with 27. Can we take 32? Oh, wait a minute. By the way, we need to put our 1 for this 32 value. Okay, now, next question. Can we take 16 from our remainder of 27? Yes, we can. So I do that subtraction and it leaves us with 11. Can we take 8 from 11? Yes, we can. So 11 minus 8 leaves us with 3. Can we take 4 from 3? No, we cannot. Can we take 2 from 3? Yes, we can. It leaves us with 1. I should have known that it would end with a 1 because we have an odd number that we're starting with. I propose that 59 in binary is 0011111. Obviously, go down to my Windows calculator here and check this. And we put in 59 in decimal and we hit the binary button and we get 111011. Notice they truncated the leading zeros when they showed us this answer in the particular display, but that's absolutely fine. That's great. We know that if we fill out the complete octet of 8 bits, we would have leading zeros. Now, what about going the other direction? What if we were to get the value in the 8-bit positions in binary and have to go to decimal? It's so easy, I'll only show you once, and that's because adding is so much easier for me than subtraction. Let me just make one up. Let's say we have 100100101. That one's got a nice ring to it. 100101. I think that's a Rush song. Anyways, here we go. What do we have in the first bit position? We have a decimal value of 128. Then we've got no 64, no 32. Then we've got a 16. Then we've got a no to the 8, a yes to the 4, and a yes to the 1. So we just need to add this up. Let's see. That's 8 plus 6 is 14, 18, 19. Carry the 1, 3, 4. We've got a 149, I propose. That is the number in decimal that I think this equals. What do we do from a sanity check as we are practicing? We cheat with a calculator. Woohoo! This time we start in decimal and we go 1, 0, 0, 1, 0, 1, 0, 1. We go ahead and click on, I messed that up. We click on binary, we clear everything, and we put the number in binary. 100100101. We click the decimal button, and we get the conversion. We verify that we did this correctly, and we then say a prayer. And why we are praying is that we get hundreds of decimal to binary or binary to decimal questions in our certification exam because they are so unbelievably simple for us to solve, and there's no gray areas with the math that you have in these tests. That's what's great about it. There's no room for misinterpretation here. It is a black or white, 0 or 1 answer. Gotta love it. So your mission, should you choose to accept it, is to review the information in this nugget on your own. Step 1, I want you to make sure you can quickly build that conversion chart that we looked at. Step 2, go ahead and come up with a number from 1 to 255 and go ahead and give the binary representation of that. Remember, you can check your work with a programmatic calculator. Yeah, not a calendar, a calculator. Step 3, go ahead and take some weird number that you create in binary, and convert that to decimal. So you'll want to go through this until all of this is very, very simple for you to do, and you want to be super fast with these calculations because you're going to need to do them in the scope of a larger, more complex mathematical calculation. So you want this to be extremely simple. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.